Welcome to the Ocean of Technology podcast, where we explore all things related to cybersecurity, data, and cloud technology.
In this episode, we'll be discussing the world of cloud-native architecture and its impact on the way we design, build, and deploy applications in the cloud.
So sit back, relax, and join us as we delve into the world of cloud-native architecture on the Ocean of Technology podcast.
The brief introduction, who are you, what do you do, and we'll go from there.
Who am I? Who am I? So Miha Kralj, I'm based in Seattle. For the last couple of years, I'm leading a cloud practice, particularly focused on cloud advisory and transformation within one of the larger engineering companies that are around. I came here out from system integration space, where for about 5 years I was working in Accenture in global cloud leadership. Before that, I worked for Amazon Web Services. Before that, worked for Microsoft. Before that, worked for IBM. So I kind of, in more than 32 years of my career, I have seen it all.
Wow. We love that. And this is why we called on you to speak. I mean, that's an impressive track record. Obviously, you're seeing new things come out every single day. So that's why I wanted to bring you on. We also like to break down complicated topics into some bite-sized chunks, so to speak. So the questions, feel free to kind of elaborate and, open it up to the non-tech audience to understand kind of how this stuff works. My background, I was previously at KPMG. I did mergers and acquisitions. And so I would help run the IT side of things, especially for some of those large integrations and carve-outs. It can be really, hairy. So I guess we'll start off with the first question. What is cloud native and how does it compare with traditional software engineering?
We will need to dive a little bit into a history and what I call IT archaeology, because without the context, I think it is really hard to understand where cloud native is coming from. So if we go to dark ages, when dinosaurs roamed the world and mainframes were popular, and very much at that time, the whole approach of what is current, what is new was very different compared to, let's say, just 2 decades ago, which was very different than just a decade ago and so on. What I'm trying to highlight here is that we have those frequent evolutionary or actually revolutionary cycles happening again and again. The cycles typically start with change of architecture. So somebody decides that we should start thinking and putting stuff together on paper or on a whiteboard in a different way. In the past, it was all let cram it on top of a CPU, and there is intra-process communication and all of that. Then we evolved further. But again, how do we capture requirements? How do we decouple? How do we do the encapsulation and government and all of the instrumentation? These are all architectural functions. And whenever there was a next idea how to do better architecture, better decomposition, the current processes were not good enough to implement, right? So typically, we always see that architecture jumps ahead, then processes, how do we architect? How do we plan? How do we develop? How do we test? All of that need to suddenly adjust because a bunch of crazy architects decided that the current is no longer fresh and new and the new black is something else. So processes are dragged along. Now you have new processes in place, and suddenly all of those developers and engineers are starting to complain about their daily tools, which we call tool chains, right? How about source control or deployment automation or release management? How do you package the software, or how do you trace it? How do you collaborate with other developers? If we change the whole processes, how we build software, now the whole tool chain is not good enough. And there is a whole set of industry and people that go, oh, now we need new tools and new editors and so kind of you go from architecture change to process change to tool chains change. And the whole cloudy thing, the platform, is kind of the last one, almost the last one in this dependency chain. How do we do the new runtime platforms or service discoverability, or do we have images or virtual machines or containers or whatever? So the whole platform, which is super important because that's where things run, is still the last one in a chain. It makes sense so far?
Absolutely.
I'm sorry for a little lecture, because now actually I'm coming to the meat of the problem. If you look in 90s, I would call that a Gothic era, right? Really, really kind of a historical. It was a monolithic architectural style. It was a waterfall development process. We, as a production tool chains, we used shared libraries of code, and we thought that that's the bomb. And the execution platform was a typical mainframe class within the CPUs of one mega machine. Roll 10 years forward in 2000s, we are no longer having monoliths. We are having client-server composites, new architectural style, which suddenly forced that the old development process, the waterfall, doesn't work anymore. And we went into a rational, unified process and a whole bunch of improvements on processes. Build automation came in there, particularly on the whole client-server world, and physical hosts, the bare metal machines, were the execution platform. 10 years forward, we come to from Renaissance to neoclassical era, right? 2010-ish, everything becomes service-oriented as an architecture. The development process is highly iterative, and we are trying things again and again. Tool chains became much more like a service, brokers and APIs, interconnectors, and so on, and execution platform, virtual machines. Now we're coming to modernism, where I would say that lots of people call modernistic era already cloud native, but it's gray, kind of a gray zone. So what we're talking about here, we need to have a new architecture, new process, new tool chains, new platform, right? So let's go again down the same list. Architecture style, microservices. Everybody talks that cloud native needs to be microservices. Development process, agile. So everybody talks that part of being cloud native, you need to have the not iterative, not old rational unified process. God forbid the waterfall, agile is a cloud native way. When it comes to production tool chains, DevOps, it's plastered all over the internet. It's no longer service brokers or anything old. And the execution platform is typically containers. But the problem is that this is kind of a present, and we already see the future. So if today is cloud native, if we are looking at the next wave that is already visible, so new architecture, new process, new tools, new platform, we're already talking about reactive event-driven architectures, which are way beyond microservices. We are talking about the lean development process, which is kind of like an offspring out from a Six Sigma and so on. We are now talking about the BizOps and no-code, low-code type of a production tool chains. And the execution platform is no longer primarily containers. It's going to serverless with a very fine-grained execution. So definitely the last one, and maybe both of the last two. So modernistic and futuristic era are probably defined cloud native. I would say that when you are using containers and DevOps and Agile and microservices, it is becoming old cloud native. So even cloud native world obviously goes through the evolution, and we need to start thinking now, particularly with the dawn of the AI-enabled development and engineering, what's going to happen over there, kind of a, Chat GPT, is that two waves forward, or, because it can write code, it can test code, it's actually its own production tool chain if you want to. I hope I am giving you a good insight. Cloud native, from the other angle, cloud native was kind of created as a disruption. If you are looking before cloud vendors, the old era, Gothic, Renaissance era, technology vendors were very much well-known and controlled the space. For networking was primarily Cisco, for hardware was HP or somebody like that, and Dell maybe for servers. For database was always Oracle. For kind of for virtualization was VMware. It was a well-placed, well-defined domain and nicely evolutionary, slowly progressed through years. Until the cloud era started with Amazon, Microsoft followed in step, and then also Google Cloud Platform. Suddenly, it's no longer evolution, right? There is that next wave that Amazon drives and Microsoft drives. And Cisco was thinking, oh, brilliant, we are going to sell so much more networking equipment to cloud providers. Except nobody bought Cisco equipment in cloud data centers. They just recoded their own. Every cloud vendor has their completely own networking stack. And HP was going, oh, great, we are going to sell so many servers to Amazon and Microsoft and Google, except they didn't buy any. They rolled their own and went straight to Taiwan to ODM manufacturers and created custom servers just for data centers. Oracle saw that, oh my God, that there will be so much Oracle inside data centers for cloud computing, but they bought none and literally rewrote the whole databases. So cloud vendors, once they started to look into scale that they need to operate at, they completely redefined the world and rejected that old ecosystem of tools and hardware and everything. And that chasm, when you reject the old, and you still need to have tools and processes and people and knowledge and all of that, and you suddenly start to just reinvent from the scratch. The whole approach that lots of people define cloud native is whatever happened after that schism, right? Schism between old IT and new IT, because for many years, the old IT was looking very smirkingly at cloud and they're going, oh, this is so unreliable. This is so childish. How can you have a bookstore from Seattle run serious IT for enterprises? Come on, right? Well, 10 years later, all of those vendors have a huge problem to stick around, and everybody is now doing something that they call a cloud washing, right? Oh, I'm doing cloud too. Look at my private cloud or whatever cloud. And suddenly the cloud native means that it is actually built from ground up with those new disruptive rules, post-schism rules. And lots of companies are trying to ride the wave and going, we have our personal cloud in pockets. We just call them phones, but they're actually personal clouds, right?
No, I love that you're talking about the different approaches, the agile and the waterfall approach, and the fact of how technology used to be, a lot slower of a growth, but now it's more exponential, right? And now that we're, the next wave is coming, and you're absolutely correct with that. So I am kind of curious though, because some companies are still using that waterfall approach with a lot of their applications, with a lot of their processes today. In your own experience, what type of projects or trends, have been kind of, taking center stage for you? Are you still using that waterfall approach? Are you, now looking for the next wave? How are you going to tackle that? What's going on in your side?
When you are an archaeologist and you go to a dig site, imagine that, right? That would be my role. And then you start digging. Do you think that I would ever find a place when there is no Paleozoic and then no Jurassic and no, everyone has all layers and you can't just wipe them clean. If there is, an active enterprise, let's say national sized bank or insurance or health provider, you think that there's going to be a bunch of kids that sit on bean bags and run around in skinny jeans and they're going, you are doing everything wrong, just let us rewrite your banking system. You think that they're going to let them? No, not really. So the ancient era layer stays, and then we add additional composite layer, and then we add service-oriented layer, and then we add a microservices layer. Every single enterprise has everything. And there are attempts to do the control and optimization, and it's called, application consolidation and so on, especially, in cases of divestiture or mergers and acquisitions and all of that. You need to put your house in order that it doesn't look too messy. But in general, answering to your question, unless you are a startup, everyone has everything.
Wow. So, I don't know if you've seen the Elon Musk technology awareness diagram or heat map, where it has like the giant tower well above everybody else with like one little point, and then everybody else like down here, and then the rest of people flat. I guess that's how you describe most of the organizations you work with. And so getting people up that mountain closer to the top is kind of what you do.
Sort of. Yeah, well, it depends. So it always comes down to whenever we talk about improving systems, so modernizations, or building new systems natively in cloud native world, The core problem is, what is the business priority? What's the business driver? It should never be what's the coolest tech. Let me grab the latest language. I mean, going to a bank and say, we will rewrite everything in Rust as a most modern, fancy programming language, they're going to show you the door really, really fast. So what are the typical business priorities? You can actually think about two different parts. One is trying to optimize existing IT, right? IT optimization, which is mostly focused on infrastructure and drives cost reduction and drives risk reduction. Sometimes it drives scalability, resilience in those things. These are all infrastructure drivers. Completely different approach, different application style. You mostly typically focus on making things stable, efficient, and cheap. And there are different technologies, different architectural styles, modern, but very different, to make stable systems, to make systems that once you launch them, you can't go, oops, our payroll system didn't run this month. Oh, it's okay, developer, our employees don't need to be paid every month anyway. You can't think that way in some circumstances. But on the other hand, you can't use the same approach with highly digital, interactive approach where your end clients, customers, are kind of a YouTube or TikTok generation that expects a new feature and a new color scheme and a new widget literally every day. So you need to have the turnaround cycle so fast that who cares about the risk and all of those things? You need to do you need to fan the interaction and stickiness. So that would be IT focused. Then you have a completely different set of drivers, which I would call business enablement, where you want to do new things. So the first one was squeezing more from less. That next, and it is contributing to bottom line. And application development for bottom line improvement is totally different than application development for top line contribution. So how do you actually enable better speed and agility and nimbleness of engineering force? And by the way, every business needs to become a software business, in case that is not very obvious. Every bank, if they want to compete, they can't just buy a system from somebody else and say, now we'll have a competitive advantage from everyone. Not at all, right? If you don't have in-house software engineering for specific competitive advantage strengths, you are going to be forgotten very, very quickly. So every business is a software business, and every business needs to decide, how do I enable my developers to be more nimble, faster, but actually most important, how do they get better access to software innovation? Face it, nobody sells new software on a DVD anymore and says, hey, install this into your data center and you are up to date. All new software innovation for a decade launches either cloud first or cloud only. And it's simply that if you want to be business competitive and an innovator, you have to use those cloud native, innovative type of services that are all rolling out from the cloud. And comes back to what is cloud native. If you're using high composite, complex cloud services, let's say already pre-built cognitive services, vision recognition, voice recognition, natural language processing, these are all cloud native services that literally with a couple of APIs, you can just integrate into a specific solution and it looks ridiculously smart. To be very practical, for example, every single app that I know that we built in the past always have somewhere in the app is a search box. You search for stuff. If you don't use the NLP for search, which means that if you use traditional pattern recognition and somebody mistypes one letter and the search goes, have none results for you, that is really old style coding. You need to grab whatever those fat fingers typed into the box, you send it over to natural language processing understanding, and you get back probably user meant this. So don't search for what they typed, search for what AI interpreted that you actually want. You kind of get the proper prompt for search back, and that's what you use for searching. That would be like a cloud native search solution, right?
It's so funny because all those little things that you don't think about, like I would have never even thought about that. Wow, it does recognize if I search something, it knows what I'm actually looking for. And, you forget that back, when I was in like fifth grade, sixth grade, seventh grade, you type something in and you're like, that wasn't what I was looking for. What even is this, So yeah, I mean, it's insane how it's integrated into almost every portion of the way we interact with technology and even, physical things as well. So yeah, Josh, do you want to take the next question?
Yeah, of course. So relating to cloud native, what are some challenges that you're personally seeing? I know you were kind of talking about how, we got to keep all the history, right? All the prehistoric, you're an archaeologist, you can't just get rid of the rest of those layers, right? You still got to keep them in there. But what, challenges are you personally seeing right now yourself?
So there is one challenge that is not like all of the others. I can pebble lots of different challenges, but again, if I would do the Pareto chart, there is one that is probably 50x compared to all of the others. So changing technology is relatively easy, right? New language, new tools, new platform, it's not that hard. Changing processes and changing business approach to processes is a little bit harder because that kind of maybe also needs to change approach to metering and billing and so on. Changing HOS, human operating system, for people that are actually going to use all of that. There is no patching that I would come in and we redevelop complete, let's say, cloud native approach to the system with a completely new user experience and all of that. And then you still get 20% of a grumpy employees that go, I always had the icon in the top left corner and now it's no longer there and I can't use it anymore. So HOS upgrades, change management, to actually proactively start to build. There is a whole bunch of tricks how cloud transformations towards cloud native are done, and I can easily share a couple of them, but that's the hardest part. How do you drag people along so nobody is left behind? Nobody should be left behind. Because we did a couple of mistakes historically, for example, going from bare metal to virtualized, and there were a whole class of IT engineers at that time that were really happy to be physical hardware management people, and they were, pulling hard drives out and pushing new drives in and doing all of the traditional hardware rotation. Where are those jobs now? Where are these people now? They're for sure not in cloud data centers, because a typical cloud data center, the one that has kind of a 200,000 nodes in it, would have probably about 16 people total on site, and that includes janitors. So we did not do very well in history. How did we upgrade the jobs, new job descriptions, new KPIs? Historically, developers were measured by how many lines of code do you write per day. Now, I really value most developers that actually write negative lines of code because they optimize code and they remove the wastage out. So by old measurements, my developers are horrible and I should fire them, right? Or the other one was measuring number of bugs. But now, how do you actually define a bug when you have the automated pipeline, which is automatically finding, checking, making smell tests in your code and not letting it forward? So because all of that automation is there, your code propagation through a pipeline stops. Nobody's harmed. It was intended to be that way. Developer slaps together possibly functional class or method and rolls forward. Let's say it gets security scan. Security scan says this smells, provides the feedback where improvement should be done. Is that a bug? Or is that something that is perfectly part of the regular development process? Because historically, bug was something that you roll to production and things explode and people are called at 3 a.m. on Sunday. And we don't have that anymore. So how do you measure developers? How do you measure IT people? How do you measure users that are using that system? What good, happy adoption curve really looks like in these days? That problem is way larger than changing processes or, hey, let's use containers and Scala coding language.
Wow.
It's
Yeah. Go ahead, John.
no problem. I was just saying that's really funny that you say that, because when it comes to, finding the talent now these days, and, when it comes to, the developers, you don't really know exactly what you need sometimes, because, it's changed so much, and the dependencies with these technologies, it's like, what do I really need? Who do I really need? And how are they going to perform on this project?
And that's why you get so many so bizarre, contradicting hiring postings out there. Looking for, let's say, Rust developer with 25 years experience. It doesn't exist that long. What do you mean?
This is the weird JDs are popping up left and right, and companies, and it goes through HR. HR doesn't really know what's going on the projects.
But look,
right? Because
here's another problem, right? Imagine, and let's go to extreme, some local government IT department that is writing things for, local government, for a city or for a state or something like that. Those jobs don't pay really well and don't attract top talent, okay? Now imagine this is the full swath of people that are probably in the industry about 30 odd years, and they're happily kind of rotating those chairs, and there is not much of the career progression and whatnot. And now suddenly somebody walks in, a new CIO that state or city hires, and now we go cloud native, and looks around the existing workforce and they're going, oh my God, what can I do with this pre-geriatric group? So we need new fresh blood, right? You go out, you hire a couple of those code ninjas that can do this DevOpsy thing, whatever it is. Let's say that you hire a nice, 5, 6 of them. Is 5 or 6 enough of them? Because after they try to do their own thing for a month, they come back and they're going, this is horrible, this is hell. I feel like I'm the only one doing work. We are the only few that is actually trying to move things. We are all quitting. So 5 is not enough. How about 50, right? Let's hire an army and they all come in, a whole bunch of those kids in skinny jeans. And now suddenly you're getting all of those pre-geriatric people that have all of the tacit knowledge of the existing systems hidden in their heads. And they're going, this place is not like it used to be, and I don't like to work here anymore. I'm asking for early retirement. And they just start to disappear. So if you go too slow, you lose the new cloud native populace. If you force too fast, you lose the knowledge that the elders have in the environment. How do you do it that is just right in the middle that you can win? It's really hard. There is no formula.
That's unbelievable that you just said that. We see that all the time in our business. And, we were listening to another podcast with the CEO of Snowflake, and he said, you have to prune the tree as it grows. A lot of these software companies did not do that. And so now these big layoffs come, and it's like, why is this happening? Well, you have specific people that have been sitting on the bench waiting, and the upgrade of talent and the knowledge transfer hasn't happened. And I can say from personal experience too, that my father, for example, he worked at the same hospital for 40 years in information systems. He built his own email server. He built out all the systems. He changed the network switches, all the, on-prem stuff that would happen. And fortunately, he was able to get into the cybersecurity side of things. So he worked his way through it, and he was able to transfer some knowledge in the process. So things are going well for him. But I know a lot of his colleagues did not have the same fortunate response. They did not pick up another side thing that kept them in the business. And so a lot of them went and started external consulting businesses for legacy technologies. So yeah, it's very interesting. It's an interesting world we live in, that knowledge transfer, the baton pass, so to speak. I saw that a lot in merger acquisition related stuff, especially when you have organizations that have not had an integration or a separation in a long period of time. They've been using the same tech stack for 20 years, and then they buy somebody else or somebody buys them, and it's like, oh, now what? So really interesting. Go ahead, Josh.
Yeah, no problem. So we'll move on to the next question here. Within, what type of frameworks or methodologies that, are kind of assisting you with project development within the cloud right now? Which are the most important ones for you?
Well, that is highly context dependent, right? Depending what type of the system, are we talking full stack development? Are we talking back-end refreshment? So instead of talking about the frameworks, probably one of the core most common approaches is hard decoupling. So that's much more of a pattern than a framework, because you can do decoupling or you don't do decoupling in most any of the frameworks. But making things so loosely connected that you can independently either replace or upgrade every component of the system without disrupting the rest of the components around is actually one of the crucial changes, which is not easy to do, but it's kind of creating that tissue, the fabric, that application is no longer monolithic, where kind of a big ball of tar that you need to replace everything. Making those changes, that systems become way more composable, that they are becoming way more modular, that they are interconnected, but they're loosely interconnected, either through APIs or through queues, message exchanges, and so on. Because that is a prerequisite that we can do anything else in the future. And that's actually one of the most common patterns also how we modernize legacy computer mid-range and mainframes and all of that, kind of trying to wrap their business logic, try to decouple components and pull them apart and put them in there. When it comes to the actual frameworks, as I said, there are many different schools of type of development. Microsoft school that kind of puts everything on top of .NET framework with 3-4 different languages that are all targeting .NET framework. Whole Azure as a cloud is very attuned, not exclusively, but it really allows you very easily to stay within that ecosystem. And Microsoft also builds development tools, Visual Studio Code, which is kind of used in the whole industry. Whole Google uses VS Code for their own software development as an editor. Microsoft has that advantage. They have their whole front end integrated development environments, IDEs. They have the whole set of languages. They have the whole set of frameworks. They have the whole set of profiling and then automation and compacting. So kind of they want to be a one-stop shop, particularly when it comes to development. AWS is great, but they provide much more loosely connected components, and they are not as integrated as they are in Microsoft sense. Google is the one that is kind of a little odd one out here. They do have their own language and their own set of frameworks. So Go or Golang is the language that very much Google is pushing, and they reinvented it more or less. Oh, by the way, I forgot to mention that Python is now sort of owned by Microsoft. At least the core development, the creator of Python now works for Microsoft, right? Every approach, and then you have that whole ecosystem, the frameworks to do proper decoupled serverless type of applications, or a set of frameworks if you want to do high velocity data streaming and not lose a drop of a data because of unnecessary buffering and so on. I would say that almost every industry is they're putting together their own scaffoldings, their own accelerators and frameworks in order to make those typical non-differentiated heavy liftings easier. For example, if there is somebody that works in a healthcare industry, which is highly regulated and controlled, there's a whole set of frameworks that whatever you code automatically goes through a full control validation. So it gets the whole PHI, PII, PCI certification. which is typically a blocker, or at least slows down a traditional, agile development process.
Actually, it's funny. We were just talking to somebody at Netrix about exactly that in the healthcare space. So that's funny that you brought that up, and hopefully we'll have her on in a later podcast episode. So stay tuned. So I wanted to skip along in our agenda, and I wanted to move into what tech stacks do you think that young software engineers should invest time into? Because there's so many out there. What do you think will be a leading technology, or what do you think is most applicable across different tech stacks?
I typically recommend to everyone to learn and relearn Git, which is not a tech stack, but understanding Git, the version control, which is actually semantically not trivial to understand, how branching and merging and hashing of pieces of code, but doing your own notes and versioning through Git and being able to write Git commands, not just use some fancy GUI that hides what actually Git does behind the scenes. That is probably for some analyst level or base level developer, I would say almost like a induction into the trade. And I'm not talking GitHub, because GitHub is a concentrator there, but locally, Git on your machine, that when you do, I don't know, you write a homework, you create a PowerPoint deck, or you create a document, that you can actually version it appropriately, that people stop doing naming of files, final v2, final for real v2 dash again. So I know it sounds weird, but that is not exactly a technology per se. Then I would say at least 2 different coding languages. Why 2? There are 2 core paradigms out there. You have a procedural coding and you have functional coding. And they are extremely different. And if you well understand one, you usually have a hard time to comprehend the other paradigm, and vice versa. Picking a language that is much more loose and procedural, let's say Python or something that is non-declarative, or JavaScript would be a typical example, something that you can kind of play fast and loose, and you can add together strings and floats, and system doesn't mind and return some other garbage back to you. These are fantastic languages for specific purposes, including data science and so on. But then knowing something that is a little bit more core, and that you understand how it works, although maybe you don't have such a fast development flow through it. And, C#, Rust, Go would come to my mind. Java is trying to keep abreast, but Java is already so old. It's as old as, I think C# is just a little bit younger, but Java didn't age very well, let me put it this way. C# got way more, just the latest iteration of C# 11 has a massive amount of functional programming in there built in directly. But looking into some much more hardcore functional languages, particularly if somebody is a CS major, is really useful. Which kind of brings me to a very interesting point, that the high-end advanced colleges don't teach any languages anymore at all. They kind of just expect that you will learn one of the languages to do the homeworks, and they don't care, do you want to build that in Julia language or Haskell or any other exotics? It doesn't really matter. So if you would look, let's say, at MIT curriculum, there is not a single language-focused course at all, because it's just assumed that this is going to be something that you pick up as you go, and you will just learn on your own. You don't need a course for that.
That's so peculiar. I've never even heard of that before, to be honest with you. I did not understand or know that, within these schools, that they're not really focusing on what programming languages that you should use, especially with how the world's moving, and that we're pushing towards all these new technologies that are all in all these new different tech stacks that are codependent and have all these different dependencies. I would imagine that they'd be like, hey, let's push for the new, or let's push for something that'll be useful in the real world. But it's kind of scary to know that that's not happening.
Well, there is, on MIT, there is a course that actually you have to write your own. You need to write a compiler for your own invented language. Small and easy, but literally, it's almost like making a mockery of the coding language industry a little bit. So going beyond languages, that everything else is kind of a wide open. I think that everyone should know how to make a quick and easy front end, which I don't want to say you need to learn HTML5 and CSS and JavaScript, but you probably need to learn HTML5 and CSS and JavaScript, just enough that you understand that there are three very different but complementary technologies that drive, phones and whatnot. And then the backend side, which particularly querying languages. So how do you get to data? And that there are different approaches to wrangle the data. The old approach to relational databases, and we went to NoSQL and to document-oriented. And now we're talking about graph databases. And very much what I'm trying to explain is that I'm not recommending one single deep direction and framework, unless somebody wants to make money and then you take, Unity and you make game and try to earn a quick buck. But in general, to have a good growth in software development industry, it's almost more important that you get horizontal literacy. Eventually, once the career matures, which is probably, I would say, 5-6 years into being a software engineer, software developer, then you start to shaping that depth. But in the early part of career, you need to start bringing your broad literacy. So ideal target within 10 years, you should be a well-shaped, T-shaped person, right? Broad understanding of everything with few depths. Whenever I get somebody that is only deep and it's functionally awesome in that one domain, but it's completely illiterate in anything else, suddenly it's becoming unbearable, because having an amazing, let's say, front-end developer that is not versed in security or data modeling, having some back-end developer that really doesn't understand how API interactions work and doesn't understand how TikTok generation consumes the data and so on, you need to be able to, at least on a high level, understand the full end-to-end story. You don't need to be a fully, hands-on master coder and have, billion GitHub submissions in there. But awareness is more important than deep expertise, at least at the beginning of the career.
No, that's awesome. We love to hear that. And I thought that was really interesting what you said about Git. I know back in project management days, Smartsheet was a big thing because of the collaboration tools. And I actually was big on learning the entire infrastructure on the security side of things to help my company document how it would use this. And just knowing the inner workings of how collaboration tools work, and how when somebody makes a change, it affects everybody else is super, super important. So I'm glad that you mentioned that.
Well, just want to let that be known.
I just want to say Git is, no matter what project, no matter what language, it just became such a de facto standard to control changes across source and documentation and everything. These days, when all infrastructure is code, guess how we keep versioning of infrastructure? With Git. Like everything in databases, changes on queries, we track that with Git. There is nothing, my whole computer that I'm talking right now on, it doesn't just have disk storage for all of the files and stuff. Literally everything on this computer is Git controlled. Every folder is under Git control.
Unbelievable.
Yeah, I was going to say, a little tidbit there for Nate over there. He is an avid Smartsheet believer. I'm not going to say we're not sponsored by Smartsheets, but he's an avid Smartsheet user. He will bring it up in almost any scenario we get in our day-to-day. He's like, we have a grocery list. Josh, did you put it on Smart Sheets?
Put it in a Smart Sheet, yeah.
Yeah, right.
Automations are so powerful, especially when I don't need to write code to do it. That's great.
So just for an experiment, try to use ChatGPT to write code. When you go there and you say, write me a code in Python that is going to do blah, and it does it. And it does it pretty darn well. And now I'm starting to see that ChatGPT is used for writing commentary in the code. You literally provide a whole block of code and you're going, comment this out, please, for me. And ChatGPT understands the code and starts writing commentary for human understanding of some cryptic, complex code. And as you said, writing the whole struts and the whole scaffoldings and all of the things that historically we were always, it just kind of went to some template or somewhere, or just, you rolled your own. If you ever coded in Java, Java is full of those boilerplates. If you want to write a hello world, you still need to have like 9 lines of code of void main and all of that stuff. All of that we can now offload to cognitive services.
I find it really funny that you brought up ChatGPT and, saying, just have it write you a line of code. I'm not going to name any names here, but we do have a couple people that we know in multiple Fortune 500 companies, pretty high up director level people that are literally using ChatGPT today, tomorrow, right now, possibly, to actually get code done, and then just something that would take them maybe 24 hours to actually figure out. They'll just have it set up, type into ChatGPT, how do I write this code like this? And then they'll just make a couple tweaks, and something that might have taken them 5 hours or 8 hours or 24 hours now takes them 1 hour, 2 hours.
So the quality of the results coming out from all of those cognitive services, ChatGPT is just one of them, is based on the quality of the prompt that you give it, right?
Absolutely.
And you write bad prompt, you get bad result. You write awesome prompt. It doesn't matter. Do you want a poem? Do you want a presentation? Do you want, DALL-E that creates images, or do you want ChatGPT to write you a code or whatever? So, is that a new potential profession, a prompt massager for AI?
Possibly, but I think what I'm thinking, right, is, Tony, you can give Tony Hawk the best skateboard in the world, right? And you can give someone else the best skateboard in the world. That doesn't mean they're going to be able to ride it the same, right? So even if, you give someone the best prompter in the world, or the best person who can write the best prompts for ChatGPT, they might not be able to still understand the code or the code enough to say, hey, I need to tweak it here. I need to tweak it there. So when
no. I'm talking that would be an isolated job. Somebody wants to get help from AI service, talks to a human what it needs, and a human is going to write amazing prompt that is fed to ChatGPT, and result is given back to the requester. So it's almost like, a marketing person that can explain things to cognitive really, really well.
Are you trying to say that these are the jobs you're hiring for right now? You're looking for someone
No, what I'm saying is that I suspect that we are coming towards the era where new jobs are going to be so different. When I was working with Disney a few years ago, and they were starting to talk, jobs of the future are going to be dream designers and stuff like that, kind of a really far in the future. But writing prompts to properly communicate with the cognitive services. So imagine how horrible that is, that we have such a buggy communication language that you need to have a special skills that you can explain to a trained cognitive machine what you want from it.
It's like explaining to one of those people that draws like the like potential criminals, like, okay, and he had black hair and he was this tall, and they're drawing the thing down.
Yeah.
Super interesting. Very interesting. Anyway, I think we're gonna wrap up here. Josh, do you want to cut us off?
Thank you for joining us on the Ocean of Technology podcast.
where we explore all things cybersecurity, data, and cloud. I'm Nate.
And I'm Josh, and we hope you've enjoyed diving deep with us. If you're looking for top-tier staffing and recruitment solutions to enhance your cybersecurity, data, and cloud capabilities, look no further than Ocean Staffing.
Our team of experts can help you find the right talent to take your projects to the next level.
Don't forget to follow us on social media and stay tuned for more insights, news, and opinions on the latest tech trends. And remember, why fish from a lake when you can fish from the ocean?